Alright, we're now ready to start implementing the second bounded context, the model of ATM. It will be simpler than the snack machine model. The only functionality it should contain is the ability to give the users cash in exchange for their bank card's balance. The ATM also needs to keep track of all charges made. This is how the implementation will look like. You can see it's a single entity with two fields, one for the money inside and the other one for the money charged. We'll start off by working on the ATM entity. Note that for this project I've chosen the first type of bounded context isolation, because the bounded contexts themselves are pretty small at this point. It means that we will gather all classes for the new bounded context in a separate folder. We won't create new Visual Studio projects for it. Alright, creating a new class, ATM. This would be an aggregate root, so I inherit it from the aggregate root base class. The entity will contain two properties, money inside and money charged. And I'm adding a method for taking money from the ATM. Now let's add some unit tests. Creating ATM specs. Good. With the first test, we'll verify that the money inside the machine decreases and that it accounts the amount of money charged from a user. Creating an entity. In order to check the money inside the machine changes, we need to load it there first, so I'm calling a load money method here. This method doesn't yet exist, we'll add it shortly. Assuming there is $1 inside the ATM, I, as a user, should be able to take it. After that, the amount of money inside must turn to 0, and the amount of money charged should be $1.01, because the commission for withdrawal is 1%. Creating the load money method. This method would just add whatever money we pass it to the money inside property. We can see it fails. That's because we need to initialize the money inside property with an empty instance. Okay, now the test fails for a good reason. It expects the money inside to turn to 0, but sees there is still $1 inside. Let's implement the takeMoney method. Just as with the snack machine model, here we allocate the required sum and extract it from the money inside property. To calculate the charge amount, we need to compute the amount with commission and add it to the money charged property. Perfect, the test is passing. Let's implement a little bit of refactoring. Let's extract the commission rate to a constant and also introduce a using statement to avoid specifying the money class here. And let's do the same in the test. Good. There still are some requirements we need to take into account. For example, what if we try to take a single cent from the ATM? Should the commission be still charged in this case? And if so, how much should it be? Also, are there any rules for rounding the commission? For example, what if a user takes $1.10? Should the commission be 1 cent or 2 cents? These are the questions we should ask the domain expert. Let's say the expert replied that there should always be at least 1 cent commission for any withdrawal operation, and the commission itself should be rounded up to the next cent. Now, as we have this knowledge, we can reflect it in our unit tests. With this test, we ensure that the commission is at least 1 cent. You can see we load a cent into the ATM and take it back from it. The money charged should be 2 cents in this case. This test will make sure the commission is rounded properly. When we try to take $1.10, the machine should charge 2 cents as a commission, $1.12 overall. Both tests are failing currently. Let's implement the required functionality. So, in order to comply with these two requirements, we need a more sophisticated calculation algorithm for the charge sum. We cannot just multiply the amount by commission rate. Here is the function we will use for that purpose. As you can see, it calculates the raw commission amount first, and then determines if the amount contains a fraction which is less than a single cent. If there is such a fraction, the method replaces it with a cent and returns the overall amount with the commission. We can replace this code here with the call to this method. Good, the test has passed. The last thing we need to add is validations. We will use the same pattern we used previously. We will create a separate canTake method, which will return an error string in case any of the preconditions are violated. So what are they? First of all, we shouldn't be able to request zero or negative sum, it just doesn't make any sense in the context of ATM. Secondly, we need to check that the money inside the machine is sufficient to address the user's request. And finally, we need to check that the machine has enough change to pick the required sum. An empty string here would signalize no errors. After we enumerated all preconditions, we can use them in the take-money method. And of course, it's a good idea to check these edge cases with unit tests. Very good, the ATM domain entity is ready. Now, as we have the domain class for the new bounded context ready, let's adjust our persistence layer. Here's the new ATM table. Note that once again I inlined the data for the money value object inside the ATM entity. Besides the money value object, we also have a money charged decimal column. I created a new ATM row for the test purposes, and I also added a new row to the IDs table. Alright, we are ready to define the mapping between the entity and the database table, creating a new class, ATM map, inheriting it from class map. The mapping here is pretty simple: the ID property, the money charged property, and the money inside value object. Good. The last thing is the repository, adding a class, ATM repository, and inheriting it from repository base class. This class will be empty because all required functionality resides in the base class. That's pretty much it. The last remaining thing here is the user interface. At this point, we can define the user interface for our model of ATM. I added a XAML view beforehand, and this is the view model for it. You can see it contains only a caption and reference to an ATM entity for now. We need to add the remaining functionality here. This is how the UI looks like currently. As you can tell, it is not functional because the view model is not yet defined. So in order for the user interface to display the actual values behind the ATM, I need to add two properties here: money inside and money charged. Now if I run the application, you can see all the values are filled out. We have the coins and notes inside the machine, as well as the overall amount of money inside and the amount of money charged. The idea is that we simulate the process of withdrawal by inserting the required sum in this text box and clicking on the Take Money button. You can see, although the values are displayed correctly, the interface doesn't react on the button clicks. To perform the actual withdrawal, we need to define a command, like this, and instantiate it in the constructor. It will execute the TakeMoney method, passing it the required amount to dispense. Note this predicate here. It's a quite handy feature of WPF commands, which allows us to define in what circumstances the command can be executed. In this particular case, we indicate that the command can be executed only when the requested amount of money is more than 0. In this method, we will follow the same steps as in the snack machine view model. We are asking if an ATM can dispense the sum for the user. If not, notifying the view and returning from the method. Otherwise, taking the money, saving the ATM using the repository, and notifying the view about the success of the operation. To display a message for the user, I need this property. And now I can define the notify client method. You can see it sets the message and notifies the view about two properties the view depends upon. We also need a repository. Instantiating it in the constructor. Good. Let's try to withdraw the money now. I'm taking $1. As you can see, the number of $1 bills inside the machine decreases, and the money charged is set to $1.01. If I restart the application, all parameters are still in place, which means that the ATM was successfully saved to the database. The last thing remaining here is actual charging the value of cash dispensed plus 1% commission from the user's bank card. We won't be writing the actual code for this here, but I wanted to show you the overall idea of how to do that. The operation we are about to perform resides in an external service, and the best way to work with external services is create a proxy class that wraps it with an API which is consumable for our application services. Here's such a proxy class, Payment Gateway. It's just a stub for a real gateway, but a real-world implementation would probably have similar interface. It's important to understand that in properly isolated model, domain classes shouldn't work with such gateways. The layer which is responsible for that is application services, view models in our case. So let's define a payment gateway here and instantiate it in the constructor. To use the gateway, we need to know the amount to charge. In other words, we need to sum up the amount of money dispensed and the commission. We already have such method in the ATM entity. All we need to do is make it public. And now we can calculate the amount and charge the payment. And again, although the payment gateway doesn't do anything at this point, this code shows how you can approach this task. Alright, we have the ATM model implemented and working as requested. In this module, we discussed bounded contexts. Bounded contexts indicate boundaries between different models and ubiquitous languages used in them. We talked about the relation between bounded contexts and subdomains. The distinction between them is that subdomains belong to the problem space, whereas bounded context is the solution for that problem. We discussed the one-to-one guideline. You should try to create a single bounded context for each subdomain in your system. But keep in mind that it's not always possible. There are 3 reasons why you might want to depart from this practice: legacy project, large codebase, and large team. We talked about the importance of drawing a context map between bounded contexts. The main guideline here is that it should reflect the actual state of affairs, not the desired one. You learned 3 types of physical isolation of bounded contexts. Keep in mind that while your code base is small, it makes sense not to separate bounded contexts physically and just keep them in a single assembly. As the project grows, however, consider extracting different bounded contexts out of it to separate Visual Studio projects or even to separate microservices. At the same time, make sure you maintain proper boundaries regardless of what type of physical isolation is chosen. We discussed communication between bounded contexts. It depends on the type of isolation you've chosen and whether or not there is an anti-corruption layer between the contexts. We also talked about code reuse. The main rule here is that you should avoid reusing code that represents domain logic. In the next module, we will talk about domain events and 2 different ways of working with them.